Ladyada.
Hey everybody, and welcome to my desk. It's a really beautiful day out today. So did some more outdoor time than indoor engineering time. We did a couple of things going. First up, do want to remind people one last time, we're shipping ADA boxes. We're almost done. You want an ADA box, you got to go to adabox.com and sign up. If you signed up and you have to update your address or payment information because it's like expired, you got to do that this week because after this week, it's over. We might not have any more left over because we're going to let anyone subscribe, and we usually fill up. Okay, so on to my desk. Got a bunch of prototypes in this week, which is great because I already like booked the final PCBs. So first up, we've got this optical sensor. You guys remember I did using, oh, it's kind of nice. You can even see the infrared LED here and then the receiver here. So this breakout, you can see when something is reflective here, something shiny is kind of the best thing here. This white, the white bottom of this PCB will be nice when this, when this is close, about like 1 to 4 millimeters away, it turns on and it can detect, you know, white versus black stripes. This is good for something being nearby or something reflective. This silver is going to be. Oh, there you go. Yeah. Yay. And then this couple things I had to change. One, I didn't realize you really do need to have this running at like over 100, up to 100 milliamps to get any reasonable reflection distance. So actually, let me get the, 1 second, get my screwdriver. Whew. Okay. This, I ended up picking a 1K potentiometer, but that was actually a mistake because you really, this at like 1, you know, milliamp, it's like almost nothing's happening here. So you really want to have, see now I have it even more sensitive because I have it at a 100 milliamp current through the emitter. So I'm going to change this to a 200 ohm potentiometer, and this I changed from 100 ohm to 33 ohms. So that means when you're running at 5 volts, you'll get at most 100 milliamps and at least like 10 milliamps or something. So it's a nice, you know, in between number. So this is nice. Worked out quite nicely. And I like, you know, like I said, I was looking for that right angle sensor. So this is going to be good for, you know, detecting stuff running by very quickly. You know, I wanted to do the index sensing for a 5¼ inch disk drive. Okay, so that one sensor got done. The next thing is I got some samples of some floppy drives, and this one, I don't actually know the exact part number because it was, you know, the part number was removed. This one is the good one that works fine. And this one, it's an older version, and it has a Sony chip here. It's like an MPF Sony series, and it has this this keyed connector. And this one is working great. You know, I love this one. But then I got this other. Let's see if I can get it out of this bin. Oh, floppy drives. I got another floppy drive. This one. And this one, hold on, maybe not that one. This one. Okay, so this one, which I can remove, it's a little blurry because it's not going to be. Okay. Okay, so this one looks almost identical. But you see it has like the sensor is exposed here. Slightly different layout, different chips. This is an MPF 920, and you know they're both Sony. You can see the Sony logo on this one, and this one is an earlier. This one is an earlier Sony one. I think it's earlier. Anyways, although I don't know, maybe it's a little later. I have to find the date codes for these. But this one has a it's like dual keyed. It's kind of weird. I don't know why they permitted this. So like the floppy connector usually has the notch, and the notch is at the bottom, but this one, they actually have the notch at the top also. So you could put the connector in upside down. That's not what I did, but it's still, this floppy drive is actually not working. It's not giving me an index pulse, although it's getting data out. And the motor's definitely spinning. So what's weird is that, like, normally you spin up the motor, you immediately get the index pulses coming out, and you get data. This one, the data's coming out, but not an index pulse. And like, I don't understand why. And what's weird is I have two of these, and they're both not doing it. So it's something with this floppy drive. There's something I have to do to tell it, give me the index pulse. And my code for the RP2040, the floppy board here, I'm coding it by hand, and I'm kind of following, like, floppy documentation. And so I'm not getting, whatever I'm doing, I'm not maybe setting some pin, or I have to gate enable something. It's not getting the index pulse. So what I have to do is, but the seller of this was like, no, I tested it in the computer. And I'm like, well, I believe you. And so I would like to have this floppy drive supported. So what I'm going to have to do is find or get some like computer with a floppy interface, and then verify it works. Just like try, inserting a disk and see if it boots. And then if that works, then I should sniff it and see like what signals is the motherboard floppy controller sending to get this going. I do know that like the density and ready pins got like recycled and reused between different drives. So yeah, interesting. This is an official Sony drive, and you can see it's really very similar to this one. There's a lot of like, you can see it's like they kind of based a lot of stuff similarly, but yeah, for some reason this is not working. This is the L. This actually looks like yeah, this is a later one. This one is earlier because this is the LML F31. This is the F34. So I'm assuming it's like 3 generations later. Anyways, okay, so that's some floppy stuff that I was also hacking on. And finally, before we get to the great search, I got a whole bunch of these cool, get this floppy drive out of the way. Floppies everywhere. Let's see. Whoop. Okay, so I got a bunch of the Pico plates in. So if you all remember, a few weeks ago, I designed a bunch of boards that would take a Raspberry Pi Pico, and like this was one that would give you terminal blocks. So this one actually worked quite nicely. Although what's funny is, for some reason, the ground trace got deleted between here, and so the reset button didn't work. But other than that, it does work fine. So let me just gently remove it. Just a lot of pins means gentle removal. Okay, so this is everything is, you got to get it the right way around. So this goes like this, and then this one goes like here, and then I think I had a demo running on this. Although let's see if it boots into a demo. Thought I had like a little, yeah, a little Wi-Fi temperature humidity demo. So this is connected to I/O and sending humidity and temperature from this SHT20 sensor. So it was just like a demo to make sure, like, everything was working. And then, the reset button works. And then you've got, these nice terminal blocks, which actually, look quite nice in the end. And, there's a little bit of a gap because there's always a little bit of a gap, but it's not too bad. It looks like they're, I spaced them just right so that they're as close as you can get pretty much. So this is, I already ordered the PCB, so that's the terminal block. So it's kind of nice because you can just connect wires. Oh, and then I did do one change to the terminal block. Can you go to the computer? I forgot I did do one little change. Terminal block. So, just give me a second. I added little wings with holes here so that you can break off the little wings. I thought it would be nice to have little mounting ears for this little guy. Okay, and the next step, coming back to the overhead, let's wrap up here. This is an underplate that you have, like this one, it just has a terminal block. This doesn't have terminal blocks, so it's going to be less expensive. It's kind of like a very, it's got nice mounting holes, but it does have the double header. And what's nice about that is you can see on like this one, you've got one row available. So you're like, oh, I want to, you know, plug stuff in. You can plug stuff in on the side. So you get like an extra, you know, exposure of all the GPIO. And then two versions. One is just prototyping plate, and then one is a doubler. So this one, the prototype plate is you've got the reset and Stemma QT, and then this one, you remember I did this, it has the battery charger. And I remember somebody was like, oh, like, is it going to bump into the battery case? The battery connector. You know, it doesn't sit all the way flat, but it still sits fairly flat. And it's actually, the reason it's not sitting totally flat is because of the little, the connector. This is a Pico H. And so you see it's got the little plastic piece for the pre-soldered headers. If I remove this and gently, and I put on the Pico W, okay, so if you see this one, it doesn't have the same, it actually sits exactly with a little bit of space left over because it doesn't have that little cross plastic piece. And it sits nice and flat. It does stick out. Yeah, these stick out the bottom, but I think that's actually kind of nice because if you wanted, you could have like stacking headers that go through. So this, let's see if I have the battery handy. Oh. Okay, battery. And then hold on, I can plug in the Stemma QT here and then plug in the battery and we'll go to the Great Search. So this is the same. See if I think the battery might be dead is the only thing. Oh yeah, it's totally dead because I left it on overnight. Let me charge up the battery. Okay, now it's going to be happy again. Let's do it. See, let me remove this camera board too. I hope it'll work. Maybe not. Weird. Okay. Well, live demo happens sometimes. But this version, I did test it overnight with the Pico W and the battery. I was having some weird issue with the sockets as well, which could be why it's not running right now. But this is both, these are both good. And then I think the only change I made for the final design is, oh, I made the default 500 milliamps on. So it's by default higher current. And then, was there another change I made? Oh, the enable pin, I added some labels so it's clear which way is on versus off. Like this is off, but like how would you know? So let me try one more time. Though I don't think it's gonna work. Bizarre. Who knows? Okay. All right, great. So this is my Pico plate hacking. And last but not least, the last demo, which I didn't get to yet today, is I got the temperature and humidity Trinkeys. This is a SAMD21 with an SHT45. So the idea is you plug it in and you can just have like instant temperature and humidity data coming into your computer or single board computer or laptop or whatever. So I just started, like I just soldered in the wires to program it and haven't gotten any farther. Okay, so that's what's on my desk. I know it's a lot going on, but let's go to the Great Search.
Where in the world is that part I need? The Great Search with Digy.
The Great Search brought to you by Digy and Adafruit. Thank you, Digy. Every single week, Ladyada user powered engineer to help you as you find things on digikey.com. Ladyada, what are you searching for this week?
Okay, so this week I was actually working on this SHT45 Trinkey. So this is a board that has a USB plug and at 7021 and then a temperature humidity sensor and a little NeoPixel. And the idea is that, you know, it's running CircuitPython or Arduino and it's like reprogrammable, but when you plug it in, it just immediately gives you temperature and humidity data. And people love the SHT45. It's a fairly good precision, a fairly good accuracy. I think it's like 2% humidity accurate and like 0.5 degrees centigrade temperature sensor, which is pretty good. You just plug it in and you're ready to go. And I actually have the prototypes. You can go over to the overhead real fast again, and I can show this. So this is the prototype. So I already built this. The idea is just a reset button. You just plug this right into your port, and you have a little capacitive touch sensor here if you want. But other than that, it pretty much just gives you temperature and humidity data. And this chip runs cool enough, and as long as the NeoPixel isn't on full blast, this shouldn't have too much self-heating. And it just comes in a 2 millimeter thick PCB, a little thicker than usual. Let's see, compared to this PCB, you can see it's a little bit thicker, so that it goes into a USB slot and it sticks nicely. It's not as nice as 2.4 millimeter, but that wasn't available for the prototype PCBs. So, but as I was doing this, I was like, oh, you know, it's been a long time since I looked at what available temperature and humidity sensors are on DigiKey. During the part shortage, of course, a lot of parts got discontinued or changed or were unavailable. But I'm actually glad I did, and I'll kind of show you how I searched for this because there's some kind of new interesting sensors that have been released and are available now. So what we want is, let's go to the computer again. So in this case, I happen to, you know, already place this part, but, you know, I might do another run. I have, you know, I stock this component, and so it's like easy to pick the SHT4 series. I want something that can run on 3 volts and is I2C. So I don't want an analog, you know, output sensor. I want digital only. So let's go to DigiKey and look for humidity sensor. So the reason I'm not looking for humidity and temperature is like every sensor has temperature. Like that's really not a special thing. Humidity sensing is done by like measuring capacitance change of this exposed capacitor. As it gets damper, like the capacitance changes. You know, a digital sensor will handle all of the calibration for you. I know people use like the low cost, like DHT11 sensors. You can even open them up and see that there's a, you know, this capacitor inside. But those are like very low accuracy, low precision, but also low cost. So we want something a little bit nicer. So let's look for an active sensor. All of these handle humidity, so that's not an issue. Look at the voltage supply later. We'll want surface mount, but I'll pick up also the dash in case that doesn't include some surface mount parts. And then I want it to be normally stocking. And just to make it a little easier, I'm not going to show the marketplace products because I just want to see what's for stock sale at DigiKey directly. Okay, there's actually quite a few sensors. A lot of these are familiar. But while I'm here, I want to change the output type to be I2C. I'm also going to pick up digital in case like that also means I2C, and then I'll pick up SPI as well. But I definitely don't want like just pure analog or PWM or just SPI. Although to be honest, there's not that many sensors like that. And then next up, you know, I did say I wanted one that would run at 3.3 volts, which is actually kind of like almost all of these fellows here. This is like the only one that isn't, so I'll skip that one. The rest work at 3.3 volts. And then, so the thing basically, you know, if you sort by, let's just put in, you know, 500 for the quantity. So you get like a quote at like a half real. If you look at pricing, basically what you're going to pay for is speed and accuracy. So the SHT40 is like a pretty good sensor, about 2% relative humidity. And I was like, oh, like the SHT45, if you look, so like there's definitely, plus or minus 3%, as well, the SHT4A, which I guess is like a lower accuracy, although, the SHT40 is very inexpensive. And I love the SHT40, don't get me wrong, it's actually a really good sensor. But let's say we wanted no worse than 2% for the temperature sensor is always going to be very good, but the humidity sensor is where you, and I want, fast response time. I definitely want 30 seconds. I think 8 seconds at the most. So yeah, the SHT30 and the SHT40 and SHT-C3 are both good. These are both from Sensirion, I believe. Yeah, Sensirion. And they're a good family. I'll say that you might want to check the data sheet because the SHT4 series has there is different base accuracy changes. So the SHT41 is improved, and then the SHT45 is even better. And a lot of it has to do with the typical and max error. So the typical is what they're going to advertise. They'll be like, oh, typical is 2%, but the max is kind of what you want to look at, because the max is where it's like, okay, your typical is 2%, but the max is 4%. So you're like, oh, because these all look like the same, like what's the difference between all these? And then if you look at the SHT45, which is what I used, hold on, it's gonna be more expensive, so you're gonna have to scroll down. Like sorted by price. Oh, it's like all the way at the bottom. It's not cheap. It's SHT45. So the SHT45, yeah, you're gonna see this one is plus or minus 1% compared to 2%, and fairly fast response time. So, 4 seconds. So you'll see each one here, like this data sheet covers all of them because it's a more recent data sheet. That's cool. They're like, you can get snappy dia parts. SHT40, typical and max. SHT41, you see the typical is about the same, but then the max is much lower. And then the SHT43, also kind of like similar to the SHT40. And then the SHT45 is where you're going to get the absolute best performance. Like the typical is 1% and the max is 2%. But what was neat is I was like, oh, well, let's actually sort by accuracy. Because I was like, well, what's the most accurate? Because like I'm used to SHT45. And it turns out there's actually another family of sensors that just came out, I guess, from TI. I've never heard of this. The HDC 30, I mean, it's just, but it's like 2022. But like they probably weren't available to purchase for like, a year or two. And this is like a really nice sensor with accuracy of plus or minus 5%, very low drift, and the temperature sensor is 0.1 degrees C. So this is actually like, I wasn't expecting to find a new interesting sensor. I go off, although of course, the typical versus the max is also not going to be the same. So the typical is 0.5, but the max is 2. And then your best typical rate's going to be, under 50%. So it's like, it's not that much different than the SHE45. Also at high humidity, it starts climbing up to plus or minus 3%. Still, it's also fairly inexpensive, $250 compared to the SHT45. And then looks like I have some discount pricing I got. I don't know. But yes, this is my pick. I'm gonna grab some of these HDC 3020s. It's good to see a new sensor. I think TI, they had a couple sensors, and you couldn't get them anymore, the HDC series. And then looks like they came back and they're like, okay, we have a new improved one. So like I said, this is, 0.5% typicals is great. I don't see anything better. Maybe I'll get a breakout going for this, and then we'll also add it to Whippersnapper. Right, that's the Great Search.
That's great search.
Where in the world is that part I need? The Great Search with Digy.
Alrighty, that's the show for tonight. If you hear a little noise in the background, it's because we have a baby. So she's just hanging out
It's
in
a
the
big-
background, watching the show, pressing buttons, doing things.
Beeping.
We'll see everybody throughout
Booping.
the week. And
Oh, you know, now my demo works.
Oh, you want to shout? Let's go to the overhead.
Well, no. Nah. And it just died. Sorry. I think there's a loose wire or something.
Yeah, do you want to shout?
Well, I don't know what happened here. It just came up and then I think the battery's like dead and it's freaking out. Never mind.
Let's get out of here.
I know. Leave while the getting's good.
Bye.
Bye.